Cool. So welcome to today's VTuber Open Q&A session. Today we're primarily focusing on a full body mocap solution for MetaHumans. This mocap solution is just driven by a single webcam, so it can be used at home, in your bedroom, in your indie studio, and it's just a really fun piece of animation blueprint that might be really useful for any independent setup. At home and in your studio. You'll only need one webcam, so I feel like some of the tips covered today might be very useful if you were to do a stream. So today we'll just be covering a few different assets. So we'll be covering first the VRM for you plugin. We'll also be covering the XR Animator that we've been exploring for the past few weeks. We've also got a new kind of like T-post asset and different animation blueprints for you to learn about retargeting mocap data as well. So really exciting to have everyone on board. On my screen here, it's just a little video showing you how this AI-based mocap works and communicates with Unreal. As you can see, I've just done this really quickly within a day, so it's not like configured perfectly, and I haven't linked all the nodes back up, but you can see that's kind of how it's working right now. So on my screen, it is an app overlay, so it's an Electron application, and it's communicating with Unreal via the VMC protocol. The VMC protocol is kind of built for VRM characters like this one, as you can see. But I've basically used this mocap data on my MetaHuman by just remapping linking up some of the curve maps and modifying some of the bone data of the MetaHuman. So I'll be going through how I did some of that roughly today. There's a bit of a workflow to follow, but I'm sure a lot of you will pick up really quickly. So this is kind of the current work in progress results. So if you haven't been following our project, this research process is a part of the VTuber Studio project driven by Offworld. It's an open source project up on GitHub for you to clone and exploit all the kind of features of the live streaming toolkit, as well as different kind of VTuber compatible blueprints that you might find useful. So every Wednesday we have these Discord open Q&A sessions, and we'll be discussing some topics, including media input and output from and to Unreal. We've also covered games packaging and different UI development before, and currently we're focusing a lot more on face body capture technology options, and alongside that you'll probably learn a little more about character rigging, skeletons, animation retargeting. And then we've also got some tutorials on avatar customization and environment building. So we'll be going through a lot of these topics in the next few weeks, but we also have had some videos on YouTube for you to follow. So yeah, this week we're really focusing on full body mocap for MetaHumans. I've been searching online for a bit now, and there are a lot of solutions built for VRM characters, but not so many for MetaHumans. So a lot of you might be looking for these options that are completely free, open source, and available to everyone. So we've just built a really, really quick version of this for the past few weeks. As I said, it's a very indie setup, so I wouldn't be expecting the highest fidelity kind of motion capture options. It's driven by a single webcam, so it's very much like pose tracking plus a bit of kind of like face mocap linking up. So don't expect the highest quality kind of motion capture, but for an indie stream, it works super well for myself. And so with this, we'll cover the kind of VMC protocol to MetaHuman workflow, and learning about how to kind of repurpose some of that VMC OSE data to your MetaHuman. And most importantly, I feel like the final missing piece from the last few weeks is solving your MetaHumans so that they become a T-pose, so that when you send any kind of like mocap data for VRM characters, it is kind of in sync and there won't be any like weird poses, default poses. So I think the missing puzzle for this week is the T-pose asset, which we'll be also going through today. So this week is a continuation of our adventure with XR Animator, which is a free AI-based mocap solution. It's available on GitHub, and I'll be posting all of these links in the YouTube video as well as in the chat over here. We've just been using the solution for the past few weeks, and it's a great full-body AI motion capture alternative to Live Link using just a single webcam or a media file. So it supports the VMC protocol, which initially was built for VRM characters, but is built on top of OSC protocol. So like Live Link, like any Rococo or any kind of mocap suits, we'll be using OSC protocol. This is just built on top of that. And you can then use this to animate your characters inside Unreal Engine using the Electron application. And it has a wide range of motion capture options, so you can choose from face only, face and upper body, face and hands, full body, or somewhere in between. And the rough workflow for today is that you'll probably need a few things in your project. If you want like a quick setup, feel free to just clone our GitHub project, of course, but if you were to build this from scratch, this is a rough workflow for you to get to where I am at the moment. You'll first need to enable the VRM for you plugin. This is also a custom plugin on GitHub that you can download that's kind of built for using VRM characters in your project. You'll then find these VMC receivers in this plugin content folder and drag them in your scene. And you'll copy some kind of blueprint and create animation blueprints for MetaHumans. So these are custom animation blueprints so that they will be driven by VMC data. We'll then retarget some of the receiving data, curve maps and bone data into the MetaHuman animation blueprints. And finally, use the Rococo T-pose to solve the MetaHuman body so that it is made for, it is easier to translate T-pose to T-pose. If you have any experience working with mocap, pose and configuration is the key to making the animations really work well. So this is the rough workflow of today. Obviously, it's quite a lot, and it's quite a hacky way to use VMC data for MetaHumans. So we'll just be going through some of the tips, and if you have any questions, feel free to just message me after or during the stream. And let's start. So before I get into how this is done, as you can see here, I already have the XR Animator running in the background. I'll just be running up so this is the GitHub. This is the GitHub repo for XR Animator. It's created by this developer Butts Young, and the repo name is System Animator Online. So in here, you can just go to the releases and download the latest version for Windows. And here I've just downloaded this zip file, unzipped it, and now I should have it over here in my Explorer. So basically I've just double clicked on it, and that's it. And it's running super quickly. It's an overlay, so it's really nice to work with Unreal and have an overlay on top because you can still see the buttons you're clicking on Unreal. So this is the first piece that you'll be needing. As mentioned, you'll also need the VRM for you GitHub page. This is a plugin for Unreal that lots of, if you've worked with VRM characters, I mean, this is just the basis of all I think lots of developers just use this plugin, and it consists of many, many useful assets. So definitely recommend having this already in your project enabled as a plugin. So once you have the VRM for you plugin ready, you can go into the plugins section in your content browser and look for VRM for you content. In here, I think the easiest way to find it is to just type VMC, and you will see that there is a BP VMC receiver. So this receiver contains a lot of information, and there's nothing we need to change in here. The only thing we need to do is to drag this BP VMC receiver into your scene. And in here, you can see that I've dragged it into my scene twice. And you can see that I have 2 of them set up. So you basically need 2. And you will also need to make sure that the IP address and port number is configured properly. So for me, I have created 2 VMC receiver in the level. One is the receive IP address. I've used localhost 127.0.0.1, and then the port number is 39539. For the second receiver, I've used 127.0.0.1, 39540. So that there's a pair of these receivers set up, and I'm just going to quickly press play simulate for you to see how to communicate with the application. So in the application, if you go into the 1, 2, 3, 4, 5, the 5th button, you'll find the VMC protocol parameters. So this is showing you the port number you should put in Unreal to communicate with this application. So as you can see, the receiver's already set up the same port number. We've set up the same port number, and the VMC protocol is on. So once this is done, I'll just click done and play simulate. And now you can see that it is communicating. So this is just a test. And of course, in your level now, you don't have the kind of animation blueprints to drive animations into MetaHuman, but as you can see, it's already communicating with the application. So what we're going to do next is going back to the MetaHuman. You'll need to create custom animation blueprints. So yeah, for those of you on Discord, I think we've started streaming on YouTube as well. So feel free to go back to the stream on YouTube to revisit some of these little tips. But feel free to also jump in and ask any questions. Hopefully, we'll be able to help. So as mentioned, you'll need to create a custom body and face animation blueprint. So when I went into body, I've duplicated I think this is the female tall underweight animation blueprint. So I've just duplicated that blueprint, and I've used and I've renamed it to MetaHuman VMC animation blueprint. So in here, I think the quickest way to replicate this process is to clone the project and copy and paste this blueprint. Copy and paste this blueprint and then drag it into and then paste it into your animation blueprint. Otherwise, feel free to just use this blueprint as it will be available on our GitHub anyway. Then what you'll need to do is using the Anim graph, we will need to get the bone data from the VMC receiver, and subsequently find, because it is a map, a map consists of the kind of bone names as well as their rotations, translations, and scale. So we basically have to find each row and break transform. So breaking the transform, you're basically breaking that row of data into 3 things. So it is location, rotation, and scale. And very simply use the transform modify bone node. Transform bone. I believe it's this one. And in here, you'll have to match each bone from the VMC skeleton to an approximate destination of your MetaHuman bone. So let's say the VMC protocol defines the left part of the left upper part of your body as left shoulder, upper arm, lower arm, and hand. You'll find that the MetaHumans are structured and rigged differently. So you'll have to choose the bones to modify to kind of match the names. So as you can see, the VMC protocol, like VRM characters, call this part of the body the left shoulder, and in the MetaHumans we don't have that, so we'll have to use the left clavicle as our bone to modify. And then upper arm, lower arm, and hand are quite intuitive, so feel free to just use them. In this case, I have found, for example, this is the left upper body, and I've looked for shoulder, upper arm, lower arm, and hand. I've broken the transform, so I'll be getting the rotation primarily. And using that, I've used transform bone and look for clavicle, upper arm, lower arm, and hand. And I'm only getting the rotation. And then in here, I've done the same for the right arm with clavicle, upper arm, lower arm, and hand. And then I've done the same for legs. So right leg, left leg, and then hips, spine, chest, and upper chest. Cool. I've just actually seen that's probably why it's been acting weird. So I forgot to change the names to left side on this. When I stand up a bit later, you'll see that the full body capture is working. Great, just noticed this problem. And I've also retargeted the hip, spine, chest, and upper chest. In the MetaHumans, we have pelvis and then spine with different numbers. So I've gone into this animation blueprint and I went for, I think, character, bones, and bone draw all hierarchy so that I can just look at which bone I'm retargeting. So I've gone for 2 and 4, which is upper chest and that kind of waist area to retarget hip, spine, chest, and upper chest. Like these should be quite intuitive. These should be quite intuitive when you just get into it. It's basically finding the row that you want to retarget and then use that data to modify the bone of your MetaHuman. So just remember to modify the bone in the skeletal control drop down, and that should be it. And one really important thing is that when you'll find that before when you first start your animation graph, it should look just like this. So the input pose will go into local and component, and then you'll be retargeting all these bones, and then it goes from component to local and then output pose. You'll see that when I hit simulate now, it might have some weird actions. So you can see that, sorry, I'm just gonna zoom out for a bit. So you'll see that, let me drag up the XR Animator. So you'll see that my XR Animator application, the character is just sitting very comfortably, and the shoulders are also fine. They're just doing their normal things. But you'll see that in here, the left shoulder, the left and right arms are entangled. And this is because I'm guessing this is because of the pose difference. So the VRM characters were made for T pose, and so when you map an idle T pose to an A pose, the angles become confused, and so you can see that the left and right shoulders are dipping in more than they should because of their different idle pose. So as mentioned, you'll need to solve your MetaHuman for a T pose, and a lot of motion capture kind of companies do have those assets ready, and that's the asset we'll be using from Rococo today. So I was just browsing on YouTube and I found the Rococo MetaHuman workflow to T-pose your MetaHuman so that motion capture data can then be used seamlessly with your MetaHuman. In here, they've generously provided the Rococo T-pose asset for your MetaHuman. So I've clicked into this link and downloaded the Rococo MetaHuman U asset. I've dragged this into my content browser. It actually might have placed it inside poses. So it would have been, so this is the Rococo MetaHuman T-pose T-pose control rig. So I haven't really had much experience using control rig, but I've found that you can add a control rig node in this animation graph. In here, you'll need to change the class, the control rig class. So what I've done is just I typed in Rococo, and for that, I've linked in the input pose to this control rig so that it will solve your MetaHuman for a T-pose, and then link it up with all the retargeting nodes in my animation graph. So now you can see a huge difference in that my shoulders aren't dipping in anymore. They're acting normally. So this is just the animation graph for the body. So we're just looking at that today. I might try to do a stand simple so that you can see the VRM character is now standing up. And I'm going to also hit play here. Maybe it would help if I hide all my bones now. And I'm going to hit play simulate. I think this view is probably a bit clearer than my level because it's more, the level has a lot of different assets, so it might be harder to see. So I'm just going to stand up in my room now and move around. Got headphones as well, so might not be able to see my legs. So now you can see that the MetaHuman is mapped to this VRM characters. As mentioned, you might have some compromises with the VRM character being more a simplified rig, and the MetaHuman being a much more complex kind of rig. So we're getting very basic pose tracking, but this is literally all done in my bedroom, so super easy to use. And now we're only getting the rotation from each joint. So we're not sending any location data, it's literally just rotation. But you can see it roughly works all right. So the hands, with this XR Animator, it also comes with fingers tracking. I haven't had the time to kind of map all the fingers individually, but I just want to show you the results. So I'm going to stand up. I'm going to see if you can recognize the legs. yeah, so the legs are working, but as you can see, the VRM character does move. It does have a bit of a spring arm effect, I would say. So you're not completely jumping off the ground all the time. It's got this really interesting spring arm effect. So this is the basic kind of intro to the MetaHuman VMC animation blueprint. Obviously, this blueprint is already available on GitHub, so I'll be linking on that. I've just updated our GitHub repo, so what you'll be getting is basically this version. And now we can look at the face animation blueprint. The face animation blueprint, I'm still kind of like halfway there, and I've linked it up. I've linked some of it up, but not all of it. So what we'll need to do is create, in your MetaHuman, go into face, and in animation, I've duplicated the existing animation blueprint for the face and created this new VMC compatible face animation blueprint. Also looks very scary, but it's basically one huge step of linking mocap data from VMC side to the MetaHuman side. So absolutely don't worry about this, and this asset is also available on GitHub, so you don't have to do this manually. So from the VMC protocol, we've got something called the curve map. So like the bone data map, it's mapping the blend shapes of the VRM characters, each row with a float. So it's a number that determines how the face moves. So can be mouth A, mouth E, mouth U, E, O. So this is like the vowels or how the mouth will move. And then we have some eye closing blend shapes, and then some facial expressions blend shapes from the VRM character, looking up, down, left, and right. So these 16 rows will be what we need to retarget into the super complicated MetaHuman curves. So the MetaHuman blend shapes are much more complicated because it's designed for high fidelity motion capture. So I think the difficulty of this part is to link all of these very simplified versions of motion capture to the MetaHuman. Personally, I think the most important parts are eyebrows, eyes, and then mouth open, the mouth openness of the character. So I haven't linked up all of these yet, as you can see. Need to study facial expressions a lot more. But an example would be finding the row face, mouth, ah, and then linking that to the jaw open. That's true, Baron. I feel like the eyes are quite important if they blink or not, and sometimes I feel like the eyebrows actually make the most difference rather than the eyes. But yeah, it's super subjective. I feel like lots of people will disagree on this. I feel like, yeah, the first thing I went for is the jaw open, which will determine, like, so all of these, my mouth, the jaw has to be open. So I've linked all of those floats to the jaw open, but then we also have to distinguish each from these from each other. So then I'm guessing this week what I'm going to do is specify how different mouth A is different to mouth E, and how and then adding some kind of math parameters to change them to these expressions. So yeah, this is super work in progress. Just been dreading thinking about studying facial expressions, but once this is done, I will quickly share my progress with you all, and it's also going to be just up on GitHub. But as you can see now, I've just roughly linked up the mouth open and joy, sorrow, fun kind of assets. Yeah, so I haven't got the E mastered. So as you can see, it's blinking. It's blinking all right, but it hasn't captured all the expressions because I haven't done all these joy, fun, sorrow ones. But the E will pull my cheeks wider, and then mouth open, R and O is slightly organic. But yeah, lots of work to be done on this side. I'm sure it will take me some time. And then the eyebrows aren't moving yet because I don't know how to link them and I don't know which expressions would work the best. But yeah, when this is done, I'm sure it will look much better. But yeah, this is basically the semi-final results of our mocap tutorial. I just also want to show you something like changing the default pose and animation of your character. I'm gonna just put this on a full screen. So in this XR Animator app, you can also change the different kind of sitting positions, which I think is quite interesting. So you can, of course, you can like stand simple. So this means that you can use your legs and change all these different, like a full, it is a full animation asset for a full body mocap, but you can also have all these really funny. This is really funny. This is like a stretching L-shaped balance pose. There are happy idle ones that is moving left to right, and a massive range of sitting animations. There's one that's really funny. This one's quite funny. It's quite like modelly. There's also legs on table. So if you prefer to have a chiller stream, or if you're like sleeping in bed while you stream, this could be the way to be. This is also really funny. But the head's angled in a certain way. Yeah, that's also really silly. Pose. So yeah, I mean, these are all just a bit of some free assets for us to use, but thank you so much for tuning in to today's tutorial. Hope that was useful. I'm sure some of you will have some questions. Feel free to clone the project and try out some of the assets, and then feel free to message me if you come across any difficulties. Setting up the VMC receiver might take some of the blueprints might also take some time, but yeah, I'm just around all the time, so feel free to message. I'm just looking at the questions now. Will there be any exploration for mixing this blueprint with live link for face capture and leap motion for hands? For sure. So yes, that's a really good question, actually. Baron might be really useful in this regard. So Baron from in this chat also has been working with a hand tracker, I believe, and using specifically a hand tracker with this with animation blueprints. So I'm suspecting what I would do is also reference the data coming in from the Rococo smart glove. So what I might do, I don't know if this is the same setup as Baron's, but what I would do is probably add a variable that is getting data from the Rococo smart gloves, and then in here I feel like the modify bone node is super useful. So as you can see, you can use the transform modify bone and you can blend it with alpha. So what I might do is actually copy and paste these. So let's say you have a hand from this this specific mocap option, and you want to do another one from Rococo, then what I would do is use the same bone name, and then link these up. And then change the alpha. So then the blend would be different. Alternatively, you can use this option as the hand rotation tracker, but then use the fingers data by just changing the bones here. So you get the high fidelity through Rococo, but you get the low fidelity AI-based mocap from this XR animator, and hopefully that will help. But I'm sure it works. I'm sure it will work by just changing the alpha so that it is additive, or like you can blend them. Alpha scale bias. Yeah, so I think this could work. I haven't really fully explored all the nodes, but we can look at if there's anything called blend. Blend poses. You won't be needing the blend poses per se. But yeah, I think I would go for this approach. Just transform bone, but alter the kind of alpha. And then link all of them up. And you can have this data could come from a completely different mocap option. It could even be like from the audio volumes, that kind of thing, like very, very new media approach to interaction. But yeah, hopefully that will help. But yeah, feel free to jump in, Baron, because I know you've got a lot more experience in this.
Hello, can you hear me?
Yes, we can hear you.
Yes. Yeah. Cool. I would not say that I have a lot more experience. I'm actually learning just as you are. I've been doing different things, so I'm not sure I could even improve on what you did. We are all like trying to figure out like custom solutions for our custom needs, basically. But yeah, I've been messing around with Rococo gloves only, and I've been using the Anim blueprint. I think we did. I think you followed the same tutorial as I did to set it up. I mean, to set up the control rig, because you're using it. You're using the MetaHuman Rococo T-pose control rig.
Yes.
So yeah, I've been doing the same thing essentially, and recently I've been building some kind of system that lets me interpolate between live mocap and recorded asset. But the imported mocap asset need retargeting in a different way. So all of this is like, it's super tricky and overwhelming still.
Yeah, I feel like with bone data and stuff, a lot of it is so manual. It's a lot. Yeah, it's so much work actually. But yeah, I'm just looking at the question. Live link for face tracking is already mapped to, yeah. So with live link, it's possible to get the individual pose, the individual floats, I feel like. So I've got this VRM plugin is great because they've tried using live link for their VRM characters as well. So I think this might help, which is getting all the morph from live link. So this blueprint might help. I haven't studied it yet, but you might be able to get the reference to live link. Let's have a look at how it's done. All right, this is where the magic happens, I feel like. So we can get individual values from a blue somewhere over here. So much stuff. So much stuff, and then blend that with the transform modify bone. Could be that way. I'm sure there's a more simplified way, but this is just right off the bat from the VRM plugin. Yes, this is more like a hacky way of doing it. I'm sure there are more ways. Or we can also, I don't know, do you have any ideas, Baron? I might try something like...
No. What I'm realizing as I learned this stuff is that I think we're all in the same boat with the Aki solutions because
Yeah.
those technologies get introduced like there's a new toy every month basically.
Yeah.
So I feel like unless you are in like a larger game development studio, it's tricky to get like actual professional support on that kind of stuff. Like it's a lot of stuff to learn. So basically, what I'm trying to say, I think those hacky solutions are pretty good. it's
Yeah. I mean, I was
it's
pretty
where it's
surprised.
at.
I was pretty surprised by it. Okay, so I'm looking at this event graph just on my level blueprint, but from LiveLink you might be able to get curves or get basic data, that kind of thing. So if you are able to store this in either a map or it could be anything, could be array, and then just use that data to transform bone, then you'll be able to blend them. So yeah, I think I mean to separate them, ideally, I'm only using this XR animator for non-iPhone users. Luckily, fortunately, I do have an iPhone, so what I might do for blending using LiveLink is for the face. So you can use the face LiveLink blueprint, but then for the body post tracking, use the XR animator. That's probably the highest quality that any solution, like combined solution, can get. Um, thank you so much. Baron was the original inspiration for this development. Yeah, Baron's been helping out massively, so thank you so much.
Oh, you're welcome.
Great.
I've been using this trick just to fix the thumbs. One of the issue I get with the Rococo gloves is like when the fingers are fine, like the last detail that you need to fix is the thumbs. So I go like individually adjust, like offset the rotation of the thumbs, and it's not perfect still, but I'm getting
Yeah.
close.
I feel like because I'm not from an like traditional animation background, I really need to learn how to study these face expressions. Like I've never cared about how a person expresses sorrow or anger, but now I have to think of like um depending on what this value is,
Uh-huh.
and multiply that to the eyebrows or that kind of thing, or like map it to a certain range. But yeah, it's really interesting. But yeah, hopefully we'll be able to recruit some kind of like research volunteers in the future for these like expressions, to study some of these expressions. But yeah, feel free. Also, if you haven't heard much about our open bit of advert time, VTuber Studio. So this is our open GitHub repo. We are super excited for any pull requests. So if you would love to contribute to the project, feel free to just drop things in and like submit the pull requests, and we'll be able to review them. And I'm sure you have probably really a lot of useful blueprints already, but we've previously collected some really useful audio blueprints from some of our community members. So this little sphere over here is a great recording blueprint that detects the microphone volume, and then some other assets. These assets are created by someone else, that kind of thing. So we're hoping to make this open repo more open source and more open to contributions as well. But yeah, thanks so much for joining today's session. I'll probably have to head off soon, but yeah, thank you so much for joining. Hopefully see you all next week or tomorrow for Jasper's session. Lovely, thank you so much.